Today we are going to train our own custom dataset that is based on under-the-sea images, and we will use the Yolo-Nas in order to train it and build our own model. Hi, you are most welcome to subscribe my channel. More videos will be uploaded soon. As you can see in this introduction video, we are taking a fresh image and we are predicting this image after the training, and you can see that it predicts pretty well jellyfish on this image, several objects of jellyfish, and the jellyfish is only one class of those images. And let's see back our original image. This is our original image, and let's go back to our predicted image. Pretty good result. Let's take another image of a starfish. As you can see, it predicted very well. The Yolo-Nas is an object detection model. It's a powerful tool for anyone looking to implement high-performance object detection in their project, and it's offering the latest advancements in AI-driven model design. And as you can see here is the performance on the Coco dataset of the Yolo-Nas over, for example, YOLOv-8 and YOLOv-6. So basically it's a very good performance and also a very good accuracy. And unlike the traditional YOLO model, Yolo-Nas incorporates neural architecture search to automatically discover the optimal network design for the object detection task. And moreover, the Yolo-Nas is more parameters and configuration tool, and it basically requires less Python coding. So you just have to know how to fill the relevant values and then run the training on your own dataset. So let's continue to the next step, which is the installation part. So now we are in the installation part. As you can see, first of all, this is the link for the GitHub for the Yolo-Nas. As always, I will leave a link in the video description to the Python code and all the relevant instructions to run this tutorial. And this tutorial is part of the object detection playlist. This is the link for the playlist for other object detection tools and algorithms. As for the installation, as you can see, first of all, we are using an Anaconda. So first of all, create an Anaconda, a Conda environment. I name it Yolo-Nas 1, and it's based on Python 3.8. Then we should activate this Anaconda. Of course, this is a command prompt under the Anaconda environment. Next, you should choose the relevant PyTorch version. I decided to run 2.1.1, and in order to discover what is the command, you first of all should run this command that discover your CUDA version. My CUDA version is 11.8, so after you know your CUDA version, you should go to the PyTorch website and look for the previous PyTorch version. The main page recommend to download the latest version. If you would like to run the same tutorial as my version, I decided to run 2.1.1. First of all, you should look what is the suitable PyTorch version to your CUDA. As I mentioned earlier, mine is 11.8, so I found that this is the command to run 2.1.1 that support 11.8. And after that, you should install the Yolo-Nas. In order to do that, you should pip install SuperGradients, and it's also relevant to install this Python library, IPython. We should use it during the tutorial. So let's continue to the next step, which is downloading the dataset and train it. Let's continue to step number 2, which is download our dataset. This is the file that contains the link for our dataset. The dataset is basically composed of classes of images under the sea. So let's go to this website. As you can see here, it's on Kaggle and it's named Underwater Object Detection Dataset. And if we go down, you can see here that there are 3 subfolders: test, train, and validation. Let's open, for example, the train. Let's open the images, and then we can see all the images here named under the sea. And the most important thing, that if you can see it right now, that the structure of the folders are a YOLO format. You can read it here. It's a YOLOv5 format. YOLOv5 format is basically the YOLO standard format. It's good for YOLOv7 and YOLOv8 as well. So the labels, if we open the labels, are contains all the relevant information for the annotations of the classes in an image. We will see it right away. And these are the classes. As you can see, the classes in the dataset are 1, 2, 3, 4, 5, 6, 7 classes, like fish, jellyfish, a penguin, puffin, sharks, starfish, and stingray. So we are going to build a model and train a model using Yolo-Nas that can detect those 7 classes. So let's click here, download, and let's open the folders after downloading. So this is the dataset. As you can see, I put it in my local machine under dataset, and it's named Aquarium Pre-Train. So now let's open, for example, the train, and these are all the images. Let's open one of the images. As you can see, there are many fish in this image, and here as well. And here we have more classes or more objects in the images. And let's go back for the first image. And what's really important to know, that we are expecting to see an identical file with the suffix of txt. If we go to the labels subfolder, so the first one is the same name as the image with the last suffix name .txt, and if we are open this one, you can see that there are several lines. Each line indicates an annotation for one object. If you remember, when we open the first image, we see a lot of fishes. So each line here is an annotation for each of those images, and these are the bounding box. They are the points for a bounding box that indicates this class. And the number 0 indicates the first class. If we go back here, we can see that the first class is a fish. So our first label contains only fishes. If, for example, we will close it and go back and choose a random file, let's choose this one. This is a fish as well. Let's try this one. Here you can see in this specific image, we can look for the name of under the images, but it contains class 0 and class 4. So class 0, if we go back, this is 0, 1, 2, 3, 4. It means that this image contains fishes and sharks in the same image. So this is how you can understand the YOLO format and download the dataset, put it on your local machine, and then we are ready to run the training. You probably noticed that not only train, we have more images like the validation images, and also we have the test images. We will take some of the images from the test folders, and we will try to detect the object inside those images after we finish the training. So now it's the training part. As I mentioned earlier, the YOLO-Nas is more suitable for changing parameters and less for Python coding. So it will be better to discover an existing code. So we should run over all the parameters instead of freestyle coding. And of course, as I mentioned earlier, all the Python coding, all the instructions will be with a link in the video description. So first of all, we will start with importing the necessary libraries for object detection with YOLO-Nas, and we will use the OpenCV for image manipulation, and all the SuperGradients here object will be for the training. Next, the main block to ensure that the code runs only with intent is using this if statement, and then this freeze support function is to ensure compatibility with multiprocessing on Windows by calling this function. Next, we are setting up the directory for saving models checkpoints. As you can see, we will store it under our dataset, and we will name it checkpoints. And next, we initializing the trainer with a custom experiment name and the checkpoint directory. So we are expecting to find this folder within our checkpoint, so we will look for all the results in this subfolder. Next, we are importing the data loading function specific to YOLO-Nas from the SuperGradient library. So these are two commands, and now it's the configuration part. We are creating a dictionary to store the dataset parameters, including the path and the class names. As you can see, the main data dir would be our main dataset. The train images dir would be train images, which is under the main folder, and also the labels. This is the subfolder for the labels, and the same for the validation data, and the same for the test data, and also we are adding the classes by their order, as I mentioned earlier. Now let's continue for the next configure parameters. Now we are loading the training data with dataset parameter and specific data loader setting. As you can see here, we are define the dataset parameter, two more parameters for the training, and the number of workers, mean how many parallel workers will run through the training, and the batch size is how many images will be in each of the batches. As you can see here, we define it with 32 images per batch. If you're running memory issues, you can try reduce by half this value. Now the same for the validation data. This was for the train data, and this is for the validation data, and the same for the test data. The next command is initialize the YOLO-Nas model with the number of classes, which is 7, in the dataset, and using a pre-trained weights from the Coco dataset. Coco dataset basically contains 80 parameters, and here we are initializing our model. Let's continue to the next parameter definition. Now we are defining more train parameters. We are defining the train parameters that include the optimization setting, the learning rate, and the metrics to track the training. For example, you can see here that we will run it with 100 epochs, and also we are going to use the Adam optimizer. I basically recommend that you use the same parameters for your model and maybe try to change the learning rate, depends on the amount of your images. So this is for the training, and here is for the validation metrics. All these parameters I recommend that you use the same with your training. And the last command initializes the training process by passing the model, the training parameters, and all the data loaders for training and validation. So this will run the train process. So let's run it. As you can see here, we are loading the train images, about 448, and these are the validation images, and these are the test images. As you can see here, the training has started. So this is the first epoch. The progress seems very well. Let's wait for the validation of the first epoch. Great. So let's wait a few more seconds for the second epoch. I believe that we can stop here and jump to the finish of the training. So let's continue. After several hours, about 3 or 4 hours, the training has finished, and let's see the results. So this is our dataset. As you can see, the training generate a subfolder named checkpoints, and if we go inside, this is another subfolder that we asked to generate, named my custom Yolo-Nas, and inside it there are more files, and the important files is these two files. One is best and the second is latest. Those are the two files that contains the weights of our training process. And the next step would be testing our model on two fresh images. I will add to the code these two images. One is a jellyfish, and we are expecting that the model would find there are here 2 or 3 jellyfish objects inside this image. And also in the second image, which contain starfishes, we're expecting the model would also detect those objects in this image. So, as I mentioned earlier, all the process of Yolo-Nas is based on configure parameters. So once again, I will add the full code. Basically, it's more parameters and less Python code. So as always, I will leave a link at the video description for all the code, including the train and the prediction. As you can see here, this would be step number 4, prediction, and the process will be divided to 2 parts. One is to run evaluation of our model over all the test images, and next we will take those 2 images. This is the jellyfish and this is the starfish, and we will try to predict those 2 images. So let's go to step number 4, prediction. We will start with importing the necessary libraries, and then I copy and paste all the information for our previous Python code. We need all these parameters to this process as well. This is where we stored all our checkpoints, all the information of the training. I mentioned it earlier, and this is the subfolder where everything is stored inside the checkpoints subfolder. Here we are choosing which weights file we would like to test. As I mentioned earlier, there was the last checkpoints and the best checkpoints. So for this process, let's choose this one, the best checkpoints. And here we are loading our model. As you can see here, we are loading all the information using our parameters. And here we running the trainer object with the test function. And we are sending the best model path and all the test data and a lot of matrix information like the thresholds. And I really recommend that you will copy these parameters for your tutorial as well. And after this process, we will print the result, and basically we will get the results for the evaluation of all the test images. I believe it will take about 5 and 10 seconds. So this is the first part of the prediction. The second part is more interesting, is taking our two images, the jellyfish and the starfish, and trying to predict the objects inside those two images. So let's start with the jellyfish. Let's go back to our code, and as you can see, this is the path for the jellyfish image, and this is for the starfish image. And we will start with loading the first image. I can see here it's a starfish. Let's start with the jellyfish, and we are reducing the size of the image since it's a very large image, and we would like that the process will be faster. So let's reduce it with 20%. We are using grabbing the dimensions of the image and resize it by 20%. And then we are running the prediction using the best model object.predict, and we will print the results, and we will use the show function of this object to display the image. Great. Let's run and see the results. Great. As you can see, the model has detected this jellyfish and this jellyfish as well, and this one, and there's another one, and here another one. Great detection, and I believe that the training was processed successfully. Thank you very much. I hope you enjoyed this tutorial. You are most welcome to subscribe my channel. I will upload more tutorials soon. Bye bye.